2.6 is about reflections of functions, reflection of the coordinate across. So I want you to think about it this way, because the way they write it is a little bit confusing. So think about it this way. To reflect the coordinate of 2, 5, if we're gonna, let's just start out with the coordinate 2, 5 is here-ish. I'm gonna do the best I can. There's 2, 5. What if we want to reflect it across the y-axis? So we want to flip it over across the y-axis, so it's symmetrical to the y-axis. We're going to change the sign of the x, and we're going to leave the sign of the y to be the same. Here we are at 2, 5, and if we have negative 2, 5, then we've reflected it across. I'm going to use it in a different color, across the y-axis. And there's our point. Okay, so now we're going to reflect it across the x-axis. In order to do that, you change the sign of the y value. So we're going from 2, 5 to 2, negative 5. So here we are at 2, and now we're going to go down to negative 5. And there is our new point let me get my blue marker here. Our new point is here. So we reflected it this way. So in short, to reflect about the y-axis, you change the sign of the x value. And to reflect about the x-axis, you change the sign of the y value. So in your textbook, they explain it this way. So if you reflect y about if you reflect a function about the y-axis, this is what you do. Now to me, that's completely confusing. So I'm going to try to simplify it for you. So if you have an equation like this, and you want to reflect it about the y-axis, remember, just if you want to reflect it across the y-axis, then you change the x-coordinates. If you want to reflect it about the x-axis, then you change the y-coordinate. So now we are trying to reflect it about the y-axis, because that's what they're asking us to do. And what we're going to do is we're going to change the sign of the x. So y is equal to negative x squared plus 4. And y is equal to x squared plus 4. So you might be thinking, well, the reflection has the same equation, and that's true, because we're supposed to reflect it. And this is symmetrical, so we reflected it, and it hasn't changed. So the equation isn't going to change. But something interesting is about to happen, because we're going to reflect it across the x-axis. So put your seatbelts on. Now we're going to reflect y is equal to f of x about the x-axis. And what we do is we change. So this is the way that they write it in the textbook. What we're going to do, we're going to multiply the entire equation by a negative. And just to go back to this, what they're saying here, y is equal to this equation. Y is equal to this equation. So what this is telling you is multiply the whole equation by a negative number. And that's what we're doing here. So we're going to go ahead and distribute the negative, or expand the negative, and we are going to graph it. And here's what we get is y is equal to negative x squared minus 4. And if you have a negative in front of the leading coefficient of the quadratic term, and not to, unload a bunch of vocabulary on you, I mean, that might have sounded confusing. Basically, if you have a negative here with a quadratic term, that's going to invert your parabola, which is here. The parabola is here. And it's going to be inverted, and it's crossing the coordinate grid at negative 4. So now we've reflected it this way. So I'm going to go ahead and draw it Hopefully I don't mess this up. Yeah, well, I kind of messed it up. But hopefully you get the idea. We reflected it, so it's symmetrical. So you go from the original to there. And really what I want you to take home, the point that I've been trying to make is, if you're going to reflect about the y-axis, you're going to change the x value. You're going to change the sign. And if you're going to reflect across the x-axis, change the y. And if it's an equation, then just distribute the negative across the entire equation.